In this video, we'll solve a differential equation using the undetermined coefficients method. And the equation is y double prime of x plus y prime of x plus 4y of x equals x squared plus 3x plus 2. Now, the very first thing that I'm going to do is calculate or solve the homogeneous differential equation. So y double prime of x plus y prime of x plus 4y of x equals 0. This is the homogeneous differential equation. So r squared plus r plus 4 is the characteristic equation, and if we solve it, we get r12 equals -1 plus minus square root of b squared minus 4ac over 2. So it's a quadratic equation, and we get -1 plus minus square root of -15 over 2, which gives us complex solutions. So plus minus I square root of 15 over 2, or we can actually say A equals -1/2 and B equals square root of 15 over 2 to write this answer, to write the homogeneous solution or the general solution to be e to -1/2 x times c1 cosine of square root of 15 over 2 x plus c2 sine of square root of 15 over 2 x. So basically, this is the solution of the homogeneous equation. Because we got two complex solutions, because the solutions don't repeat, we can go and conclude that our particular solution will have a shape of the function that it's on the right hand side of the equation. So basically, because it's a quadratic one, we are expecting our particular solution to have the form ax squared plus bx plus c. So our goal is to actually find a, b, and c. Find them. So how do we do that? Well, let's calculate the first derivative of the particular solution. So we get 2ax plus b, and the second derivative of the particular solution, which is 2a. That's it. And now let's replace them in, let's call this equation star. So replace y particular prime, and y particular double prime into star. So what do we get? Well, y double prime is 2a plus y prime is 2ax plus b. And then y is ax squared plus bx plus c, but in our equation is times 4. So it's 4ax squared plus 4bx plus 4c, everything equal to the right hand side, x squared plus 3x plus 2. So now on the right hand side I have a quadratic equation, on the left hand side I have a quadratic one. So I'm going to arrange them accordingly. So it's 4ax squared, I'm going to put this term first. I have terms in x, two of them, so plus 2a plus 4b times x, and then plus 2a plus b plus 4c. So we rewrote on the left hand side the equation as a quadratic one, and on the right hand side x squared plus 3x plus 2. When are two equations equal to each other? When their coefficients are equal. So the 4a is equal to the coefficient of x squared from the other side, so 4a equals 1. The 2a plus 4b equals 3, so 2a plus 4b equals 3, and let's color code it green, 2a plus b plus 4c is equal to the constant, so 2a plus b plus 4c equals 2. So this is a system of equations, it's not a complicated one, so a it's 1/4, I'm going to substitute in the second one. So 2 times 1/4 plus 4b equals 3. So we get 4b equals 3 minus 1/2. So 4b equals 5 over 2, or b equals 5 over 8. So we found that. We found a. Oops. A equals 1/4. So 2 times 1/4, I'm going to replace both of them into the third one, plus 5/8 plus 4c equals 2. So we get 4c equals 2 minus a half, right? 2 times 1/4 is a half, minus 5/8. So 4c equals, I can multiply this one by 8, this one by 4. So we get 16 minus 4, that's 12, minus 5, that's 7 over 8. So c equals 7/32. So then the particular solution is 1/4x squared plus 5/8x plus 7/32. So we have our general solution, it's here, and then we just found the particular solution, it's here. So basically the solution of our equation is the general solution plus the particular solution. So if I put them together, it's going to be e to negative a half x, if I remember it correctly, c1 cosine of square root of 17 square root of 15 was it over 2? 15/2x plus c2 sine of square root of 15/2x plus 1/4x squared plus 5/8x plus 7/32. Now, if we have initial conditions, so if, for example, they give us that y of 0 equals 1 and y prime of 0 equals 0, if we have initial conditions, we are not going to apply them just to the general solution or just to the particular one. We have to apply to the whole solution, the general plus the particular. So for these two, I made them up, so we'll see what we can come up with. If we have y of 0, if we replace here, we are going to get c1 plus 7/32, and that it was given to equal 1. So basically we found out that c1 equals 1 minus 7/32. So c1 equals 32 minus 7, 25/32. We found the first constant. Now in order to find the second constant, c2, we'll have to differentiate y prime of x. Right, so we'll have to differentiate this and then replace x with 0 and set it equal to 0 to find the constant. So I'm going to pause and do the derivative. You can pause and do the derivative as well. So I calculated the derivative of y. Be careful when you differentiate this side, this piece, use product rule, right? You have a function e to a power and then times another function. So use product rule. We differentiated e to negative 2x first, negative or half x, and then we copied the second parentheses, and then I kept the first one and I differentiated the second parentheses. Now let's replace with 0. So y prime of 0 is going to be negative a half c1, and then plus square root of 15/2 c2, and then plus 5/8, and this is set to equal 0. So c1 we found it, so it's negative 1/2 times 25/32 plus square root of 15/2 c2 plus 5/8 equals 0. So we can find c2 no problem. So square root of 15/2, because I made up these problems, of course the numbers are a little bit weird, plus 25/64. So square root of 15/2 c2 equals, we multiply by 8, so we get negative 40 is negative 15/64. So c2 equals negative 30/64 square root of 15, which is negative 15/32 square root of 15. I can actually rationalize. We're used to rationalizing, and also it's nice because these two cancel nicely. So basically, y of x is going to be whatever we got all the way here, in here, right? That's y of x, but we can replace c1 and c2 with what we got. Let's see if I have enough room. E to negative a half x times c1, 25 over 32 cosine of square root of 15 over 2x. I chose, let me write a little bit down so that it doesn't intersect my c2. So y of x equals e to negative a half x c1 25 over 32 cosine of square root of 15 over 2x plus c2, so minus square root of 15 over 32 sine of square root of 15 over 2x plus 1 over 4x squared plus 5 over 8x plus 7 over 32. So the main part of this problem was when you have initial conditions, replace them only in the final answer where you have general and particular solution, where you have the solution of the homogeneous equation and the particular one.